Hello, this is Professor Urbis-White. Today we will talk about inequalities and different notations used when you solve inequalities. Let's get started. Now, to solve inequalities, put the variables on one side and then use addition property, and it's very similar to addition property of equality. And then use multiplication property. Beware of negatives. I'll just show you when the coefficient is negative. And get the answer, and then always check. Then read the question and then see if they asked you the question in certain notation, and then you have to answer the question with that notation. So let's get started. Let's go over notations. There are three types of notations I want to go over. The first one is called set builder notation. You're going to use braces for that one, and those are called braces. I do them with like a little half circle, a nose, and a half circle. Half circle, a nose, and a half circle. I saw a lot of versions of that. So interval notation. That one is going to be, you'll use parentheses, or you may also use brackets, parentheses and brackets, depending upon the situation. Or you can kind of double them up like that. And then there's going to be a comma in the middle. And this first number is going to be the small one. If it's negative infinity, is the smallest one you can imagine. And this number is going to be the big number. So you have to put small on the left and a big on the right. And then there's some called a number line notation. And for number line, you're going to put 0 in the middle. This one says x is less than 2. So you'll go to 2. When it's less than, you're going to show it as a bubble. I kind of exaggerated, indicating that 2 is not included. And everything to the left of 2 is included. Sometimes I do it like a squiggly. So, x such that, and this one is called such that. X is less than 2. The interval notation equivalent of that is 2, all the way to 2, all the way from negative infinity to 2. And on the number line notation, everything to the left of 2, excluding 2. All right. Let's do this one. X is such that x is less than or equal to 2. So everything up to 2, from negative infinity to 2. And for the number line, you're going to have a 2. This time you're going to show it with a black dot to the left of 2. Now, in some books, you will also see this. Bracket facing left. And with the same token in the previous example, you may also see this. 0, 2. Parentheses facing. Okay? Does it make sense? All right. Let's look at the next one. Now, this one is saying x such that x is greater than 2. That means 2 is the smallest value, excluding 2, all the way to positive infinity. It takes parentheses because 2 is excluded. And positive and negative infinity never take brackets in the interval notation. So it has to be a parentheses. So it looks like this is good. 0, 2. Now I want 2 and bigger. Open circle to the right. Or, remember what I said? Parentheses to the right. Okay. So let's look at another one. 2 is greater than or equal to 2. X is greater than or equal to 2, so that means that's going to take a bracket. all the way to infinity. Infinity never takes a bracket. How do you show that? 0, 2, black dot to the right. You can also show it 0, 2, bracket to the right. Good. Now how do you do between problems? X is such that x is greater than or equal to -2 and less than or equal to 2. Okay, that means bigger than -2, less than 2, but I want 2. Bigger than -2, the small number, big number, and it takes a bracket because of that equal, and this takes a parentheses because there's no equal there. So how do I show that? -2, 2. It's between -2 and 2, that's for sure. And I do not want -2, and I do want 2. An alternate notation, -2, 2. I can put parentheses and bracket like that. It is kind of similar to that notation. All right, so let's do some simple examples. But before I do that, I want to show you some mistakes. All right, here's a mistake. These guys will never face each other like that. It will never happen. These guys will never each other like that. It will never happen. They will all go this way or they will all go that way. But this is good. They all go to the right. But the problem is this is greater that way, right? And this one is big and this one is small. How can a small be a bigger one than a bigger number? So you cannot put a big number here and a small number here going that way. Look at this one. Now they're going this way. That's good. But the problem is this is supposed to be the smallest number and it's supposed to be the biggest number. In this case, this is big, this is small. So that's not going to work either. How about in this interval notation? I told you this number is supposed to be small. This number is supposed to be big. And what happened here? Big, small. So that's not, none of that is allowed. Okay. How about some of these guys? Okay. What's the problem with that one? There are a lot of problems. Negative is on the right, positive is on the left. That's not allowed. That's a big problem. And here's another problem. A bracket in an infinity, not allowed. Braces at infinity is not allowed. Again, big, small, that's not allowed. Okay? How about here? A lot of problems here. A bracket here, a braces here. Neither one of them is allowed. And a big and small, that's not allowed either. So pay attention to these notations. Okay, so let's do this example. Solve an interval notation. So what do you need to do? You are going to isolate x. So subtract 4 from both sides, just like you do. And this one is not going to change when you subtract. Then you're going to end up with x. 5 minus 4, 1. X is less than 1. And remember, the direction of the less than stayed the same the whole time. Now, interval notation. That means the biggest value is 1. What does that mean? The smallest value is then negative infinity. And this is going to be parentheses and parentheses. Very good. So I solved the problem in interval notation. How about this problem? 3x greater than negative 6. I wanted a set builder notation. I want x isolated. That means I'm going to divide both sides by a positive number. That doesn't change the direction of inequality. 3's go. X is greater than negative 2. What does that mean? The smallest number I can think of is negative 2 excluding negative 2, and I want it in set builder notation. Braces x such that x is greater than negative 2. Braces. Very good. All right. How about this example? 2x minus 5 greater than 7. Now I need to do the addition property first. Add both sides 5. That doesn't change the direction of equality. You have 2x, and then these two 5 will go. 7 plus 5, that's 12. Now I have 2x on one side, 12 on the other, but I need to divide both sides by 2. That also does not change the direction of the equality. 2's will go. I'll have x greater than 6. How do I show that? In number line notation. Zero, here's 6. X is greater than 6. Open to the right. Very good. Okay. Let's do be careful examples. So what did I learn? When I subtract, the direction does not change. When I divide by a negative number, the direction does change. Did you see that? This one stayed the same. This one get reversed because of this negative 5. All right. When I have some like that, what do? There's a negative in front of x. That is the same as doing this. So think of it that you're going to divide both sides by negative 1. And remember what you do when that happens. You write the x, but what happens to this? It's going to reverse. Negative 5 divided by negative 1, that's 5. Same token, when you divide both sides by negative 5, this is going to change. But the thing is, this is going to change. Since it has the equal, it's going to change this way. All right? Does it make sense? So be careful with those, but you'll be fine.